Good morning, students. You are welcome back to mathematics class, and my name is Edu-Tech. I believe all assignment has been submitted, and you are all ready for this class. Okay, I'll be taking you through simple equations. In our last class, we discussed about factorization, word problems on algebraic expressions, and we concluded it on simple equations. So we are going to continue from there today in this class. Before we proceed to what we have for today, we are going to talk about the correction to the exercises that was given. That is the assignment that was given. I know that you've done justice to all the assignments, but if you are having challenges in some questions, please listen carefully as I do correction to all the exercises. Now, you are to use the balancing method to solve the following equations. This is an example of simple equations. These are examples of simple equations. We have numerous and thousands of them out there. Okay. Now, what I will just do is that I will not be drawing this because of the space of our work and because of our time. I will not be drawing the balancing this thing because it will be occupying much space. But I think I've taught you how to draw the diagram. You understand? Now, what I'll just do is I'll just draw. Okay, I'll draw on this side, then I'll solve on this side. Okay, from question 1, x plus 5 equals what? 6. What is the thing that you're going to do? Subtract what? 5 from both sides. If you subtract 5 from both sides, what do you have? X equals what? 1. So that means you have your balancing this thing. You have x on this side and you have 1 on this side. That's all. Now, the next question. You have 51 equals 5 plus 23p. How do you draw this? 51 will be on this side. Then 5 plus 23p will be on the other end. Okay. Now, same thing applies. Subtract 5 from both sides. If you subtract 5 from both sides, that means you're having 51 minus 5. And that will give us what? 46. 46 equals 23p. Now, divide both sides by what? 23. That will give you p equals 2. So that means this is 2. Then this is p. You know, any other, like either way around, p can be here, 2 can be there. Does not really matter. This is for question. This is question 1. This is question 2. Now, question 3. 10y plus 7 equals 87. Same thing applies. Subtract 7 from both sides. That means you are going to have 10y equals 80. That means y equals what? 8. So I'm going to have 8 inside here. Then y inside here. That's all. Now the next question. 2y minus 3 equals, this is question 4. 2y minus 3 equals 21. How do you do this? Add 3 to both sides because you want the unknown to be on a separate part. So you will add 3 to both sides. That will be 2y equals what? 24. That means y equals what? 12. That means you have y here and you have 12 here. Balance. Is it balanced? Yes, it's balanced. The last question. 9 equals 5x minus 16. 9 equals 5x minus 16. Add 16 to both sides. That will be 25 equals 5x. That means x equals what? 5. So this is x and this is 5. Now, before we move on to what we have for today, I want to explain something before we move on. The meaning of balancing method means what is on the right hand side, is it equivalent to what is on the left hand side? Now let me give you a quick and sharp method to use. Now, what is that number that when you add with 5 that will balance the other side? That is 1. Then the next question, what is that number that when you multiply with 23 and you add it with 5, the result will be 51? That will make this side to be balanced. What is that P? Then, what is that number that when you multiply by 10 and you add it with 7, the result will be 87? So, that will balance this side. That is, it must be balanced. What is on this side must be the same thing as what is on this side. That is when it will be balanced. Same thing also applies to this. Now, let's look at what we have for today. We are going to review the use of balancing method to solve simple equations. I think I've explained that in the course of the correction. We will solve simple equations using the method of collecting of like terms. Now, in our previous class, I explained to us that we have several methods. Okay, we have 2 methods. The method of balancing method, then the method of collecting of like terms. Then we look at simple equations that involves fractions. So this is what we are going to deal with in this lesson. Now, we want to solve simple equations using the approach of collecting of what? Of like terms. Now, what are the steps that we need to follow? First, identify the unknown. Once you are able to identify the unknown, then definitely your work is still half solved. Now, combine all the terms of the equation on one side. What does that mean? Combine all the terms of the equation on one side. Let me explain this. What it's saying is that it's not saying you should combine all the terms, that is all the like terms. The one of x to one side and the one without x on the other side. That is the meaning of that statement. Now, addition and subtraction can be carried out across board of the equation. That is, what you do on this side must also reflect on this side also as well. That is the meaning. Then you can divide by getting the unknown. Okay? Now, let's solve this first example. Solve the simple equation 7y minus 4 equals what? 24. Using the method of collecting of what? Of like terms. Now, there are 2 ways of doing this. It's either you transfer minus 4 to go and meet 24. And once it crosses this bridge, it will change to what? To plus. That is 7y equals 24 plus 4. That is 7y equals 28. Okay. And you divide both sides by what? You divide both sides by 7. This is 28. So that means y equals what? 4. Or, the way we used to do, add 4 to both sides. So when you add 4 to both sides, this becomes 0. That will be minus 4 plus 4. Then equals 24 plus 4. That's all. Now the next one, 2x plus 7 equals what? 19. Same thing. Subtract 7 from both sides. Plus 7 minus 7 equals 19 minus 7. That is 2x equals 12. X equals what? 2. We have 6x minus 2 equals 18 minus 4x. Now, this is now to that point 2. Combine all the terms of the equation on one side. Do you see now? This one is scatter abroad. Scatter across board. Right? So you will need to gather the ones that are having the same term on one side and the other one without x on the other side. Now, how do you do this? There are 2 ways that you can do this. It's either you add plus 2 to both sides so that this one can stand alone. Then you later add 4x to both sides, or collect the like terms. Transfer minus 2 to this side, then transfer 4x to this side. Now, let's do it. Let me do it step by step so that you will not be confused. 6x, I want to transfer minus to this side. That will be 18 minus 4x. Now, once minus 2 crosses this bridge, it will change to what? Positive. Then again, I want to transfer minus 4 to this side. That will be 6x plus 4x equals 18 plus what? 2. Now, 6 plus 4, that will be 10x equals what? 20. X equals 2. That's all. Okay, look at this. Okay, pick your pen and paper. I believe you are with your writing materials over there. Okay, pick your pen and paper and just solve this. 18x minus 9x equals 15 plus 2x. What is x? Okay, now, in solving this, first, 8x minus 9x is what? Minus x equals 15 plus 2x. Now, you can do this either way around. Either you transfer minus x to this side, or you transfer 2 to this side. But so that you don't be confused, let me transfer 2 to go and meet x. That will be minus x. Don't forget it's positive 2x. Crossing that bridge it will be what? Minus equals what? 15. And this will give us minus 3x equals 15. So what is x? X equals minus 5. Yes or no? Because you are dividing both sides by what? By minus 3. And I've taught you under directed algebraic terms that when you are dividing positive by negative, it will be what? Negative. That's the answer. Now, another question, we have to solve the equation minus 7p plus 12 plus 4p equals minus 27. Now, collect the like terms. The ones that are having the same terms, p, take it, bring them together. Then the ones without p, take it to the other side of the what? Equation. That will be minus 7p plus 4p equals minus 27. Now this is plus 12. That will be minus what? 12. Now minus 7p plus 4p, that will be what? Minus 3p. Minus 27 minus 12, that will be minus 39. And that means p equals minus, that will be p equals plus 13. Because you are dividing both sides by what? Minus 3. And when you are dividing by minus, that will give us what? Plus. Under directed algebraic terms that we've done so far. Okay? So I believe you understand what I've been doing since. Hope you are following. Now, look at this. 12 minus 29x minus 48 plus 11x equals what? 0. Now, the ones that are having the same term, x, put them on one side, and the one without x, transfer them to the other side of the equation. Now, let's do that. Minus 2x, minus 29x rather, plus 11x should be on this side. Then equals, I will now transfer the ones without x to the other side. That will be 48, because 48 is negative here. Then 12 is not negative, though it's kind of positive. That will be minus 12. Let's do this. This will be minus 18x equals 48 minus 12. That will be what? 36. Divide both sides by minus 18. That will be x equals minus 2. I don't need to explain that again. You understand how it comes by. So you divide both sides by minus 18. Give you minus 2. Now, I want to mention something again as well. I want to expatiate on something. so that you will not get me wrong. Whenever you are having the same terms, let them be on one side, and the ones without x, the ones with letters, let them be on one side, and the one without letters, let them be on the other side of the equation. It does not matter the way you arrange it. You might do your own and just transfer this to this side. That is x, the ones with x, I mean this and this, transfer it to this side, and leave the ones without x on this side. It's your choice. But still, I know you will get the same thing. Okay, now pick your pen and paper. Transfer this x, 29x, minus 29x and 11x to this other side. Then leave 12 minus 48 on this other hand and solve it and see. Maybe you will not get the same answer. You will. You definitely do. Okay. Now, we want to move on to the next, which is simple equations involving fractions. Simple equations involving fractions. Simple equations involving algebraic fractions are those that often contain either the numerator or the denominator or both with certain unknown. So it's either the numerator has an algebraic term or the denominator has an algebraic term, but it must be fraction. It must have a numerator and a what? A denominator. For example, if you have x over 2 plus y over 2. This is an example of sorry, this is not a simple equation because it involves two unknowns. This should be let me say 3x, and this should be 3. For example, this is just an example. So this is an example of a simple equations with what? With fraction. Now, how do we now solve them? To solve the simple equations involving fractions, first find the LCM. That is the most important thing. And it's just our normal HCM that we use in solving fractions. You know, in our JSS1, we taught, like you were taught how to solve fractions. 1 over 2 plus 1 over 3, find the LCM, 6, and this and that. Then carry out the necessary operations. That is, the operation can be what? Multiplication, can be division, can be addition, can be what? Subtraction. That is the meaning of the operation that we are talking of there. Now, solve the fractional equation. 15 over 2x equals 3. 15 over 2x equals 3. That is 15 over 2x equals 3 over 1. Now, how do you go about this? What you're going to do is you cross multiply. That is the first step. So that means 15 will multiply 1, then 2x will multiply what? Will multiply 3, right? So that will give you 15 equals what? 6x, right? As I've mentioned earlier on, that it does not necessarily mean that your answer, that is the value of your known for your unknown, is not necessarily that it should be whole number. It can be what? Fraction. So from here, your x equals what? 5 over 2. Yes or no? Yes. That will be 15 over 6, right? 3 there, 5, then 3 here, 2. Okay? That is all. Then the next one is to solve for the unknown. We have x over 2 plus x over 3 equals what? 12. Now, what do you do? Find the LCM. That is the first thing. The LCM of this is what? 6. Then this will give us 3x plus what? Plus 2x equals what? 12 over 1. Then you cross multiply. 2x plus 3x will give us what? 5x equals 12 times 6 will give us what? 70. Sorry. That will be 72. Divide both sides by 5. 5. That means x equals 72 over 5. That will give us what? That will give us 14 whole number. 14 whole number 2 over 5. Now the next question, solve the fractional equation. X over 6 plus x over 4 equals 9. X over 6. I don't need to be writing the question self. You already have the question there. Let me just solve direct. Okay. Find the LCM of 6 and 4. That will be what? 12. I don't need to teach you how to find the LCM by now. I think you know how to find the LCM of a number. Okay. This will be 2x plus 3x equals 9 over 1. Cross multiply. This will be 5x equals 108. Okay, divide both sides by 5. By 5. That will be x equals 5 here 2, 5 here 1. That will be 21 whole number 3 over 5. That's the answer. The next one is solve the fractional equation 3x over 8 minus 1 over 4 equals what? 10. Now what is the LCM of 8 and 4? The LCM of 8 and 4 is 8. So 8 in 8 is 3x. Then in 4, that will be 2 equals 10 over 1. Cross multiply. That will give you 3x minus 2 equals what? 80. Right? Then collect the like terms. That will be 3x equals 82. Divide both sides by 3. By 3. X equals 3 here, 2. Remainder what? 1. In 12. Oh, sorry, remainder 2. In 22. That will be 7. Remainder 1 over 3. 3. Okay? Yeah. I think it's clear. That is 27 whole number 1 over 3. This is 21 number 3 over 5. 14 number 2 over 5. Because I've explained to you that it does not necessarily that you will have a whole number when you are solving. Okay? Now, don't forget what we've learned. When you are solving a simple equation, use the method of collecting of like terms to solve. The reason why we are using that is because to use a balancing method, you might have an ambiguous equation, a very long one that you need to, put one in the other, put the other, so it will be very, very, it will be very tedious. It will not be easy for you to be drawing the balancing diagram, draw it here, draw it there, draw it here. So it will look somehow. So that's why we employ the method of collecting of like terms. And in doing that, you must collect all the terms, the like terms on the same side, and the other side and the other one on the other side. So and you can do this by adding or by subtracting, or better still, you can transfer the term across the equality sign. So you can do that. Then we discuss about the fractional or simple equation, how to solve them by using the method of LCM first. Then you can cross multiply. Then you can carry out your operation. Maybe you add, maybe you subtract, then you divide, then you have the value of your unknown. So I believe I've been able to do a lot of justice to all questions arising, and I've been able to at least shed more light on simple equations, how to solve them using the method of collecting of like terms, and how to solve fractional equation. Go through these slides over and over again, listen to them, and I know you will definitely understand what I'm trying to pass across. Now your exercises, which will be submitted, should be submitted to the mail on the first screen, tope.ilesomi@greenland.org. That is how you can reach me. Solve the following equations by collecting like terms. X plus 7 equals 15. 16 minus 3x equals 5x. 2x plus 1 equals 25. Then solve the following fractional equations. 3x over 8 plus 1 over 4 equals 10. 3 over 2x minus 1 over 3 equals 5 over 6x. 5 over y minus 1 over 2 equals 2. Don't forget, there are many ways of solving in mathematics. It does not really matter that you follow my own method. Like I did here, you can collect your like terms here. Instead of going through this, you can just transfer this to this side. That will give you 3x over 8 equals 10 plus 1 over 4. Then you find the LCM there, and you still get the same thing. But if it is this, you can't do that, because this and this, they are the same term. Understand? Okay. Now for your further readings, check your STAN Mathematics, New General Mathematics, and this YouTube link will be of good help. Watch the link, watch the video using this link. It's about simple equations. Then Mathematics in Focus for GSS2 will be of added advantage. Solve questions, ask questions. Forward your questions to the mail. All your questions, all your matters arising, everything. So send it to me through this mail and I will reply you. Thank you very much for your time. Take care. Bye.